let's see some examples now. So we have learned the technique. Now let's apply that to some examples. So this is our x of t here. And what are the critical points? The first step is always to identify the critical points. It is at the origin and at 1. Okay, great. So now let's try to find out this x1 of t. Okay, the critical points have now got mapped on to the 0, now got mapped on to 0 itself. So another nice thing that you have to remember is, if 0 is getting mapped onto 0, that means there is no origin shift, which means b is 0. Okay, so just by looking at a signal, if the origin has not been shifted, you can immediately say that the value of b is 0. So it's a nice trick to remember. All right, and the critical point 1 has now been moved to -1. Okay, so going back, just look at this formula. So we have that A is T2 minus T1 by V2 minus V1, right? So all you have to do is just know the values of T1, T2, V2, V1, and let's say here T1 is 0 and T2 is 1. Then in the numerator we'll just have 1 minus 0. Let's call this as T1, this as T2, and the corresponding values of V1 and V2 would be so and so. So we'll have minus 0, which gives us minus 1. So A is equal to minus 1, and B is automatically 0, because anyway the origin, so it directly follows from this, if there is no shift of origin, then B naught will be equal to 0, which automatically makes B naught B to be equal to 0, right? That's a nice way of directly finding out B. So this is 0, which means x1 of t is equal to x of minus t. All right. Now let's figure out what happens to x2 of t. Now, if you see, the shape in time only has not changed, but the value of the signal itself has now changed. So here it was a completely positive, signal, but here it's a completely negative signal, which means here x2 of t is some c times x of at plus b. Okay. In other words, the amplitude of the signal has now been altered. So not only the time is manipulated, but the amplitude is also manipulated. Okay. And in what way it is manipulated? If you can see here, 1 has become minus 1, right? So all we are saying is, at some point 1 has become minus 1. So from this it is easy to figure out that C is equal to minus 1. And once again, the shift of origin has not happened here, which means V is 0. And the time instances, as you can see here, the critical points are still remaining the same. V1 and V2 has not changed, which means A is just 1. You can just substitute in this equation, and then if you substitute in that equation, actually you will get 0 by 0 form. So if you are getting 0 by 0 form, then you have to keep in mind that nothing has changed, so it has to actually be equal to 1. So if you get 0 by 0, don't say that it is undeterminate or it is infinity or anything. It means that T1 is same as V2, T1 is same as V1, and T2 is same as V2. So which means there has been no scaling whatsoever. So A is just equal to 1. Okay. So in other words, here we have x2 of t to be equal to just minus of xt. Okay. Now, in fact, the last one here is exactly of this same form. x4 of t is c times x of a t plus b. Once again, the critical points remain at the same time instances, which means this is just simply c of x of t. Only thing that you have to now check is what happens to the value of c. So just take a point which is non-zero. So 1 gets mapped onto 2, which means 2 is equal to c times 1, and c is 1. So the answer is x4 of t equals 2 times x of t. Now let's see another and final example, x3 of t. So there is no change in the amplitude, which means this is simply x3 of t is x of a t plus b. Okay, let's find out A. The critical points have now moved to different locations. So T2 minus T1 is just 1 minus 0. Now we have V2 to be 2 and V1 to be 1. Okay, this still gives us just 1. So which means there is no scaling operation in time. We just have A to be equal to 1. What is B? There has been a shift of origin. So this is minus A times V naught. V naught, or in this case V1, is 1, which means this is equal to minus 1. In other words, we have x3 of t to be equal to x of t minus 1, which makes sense because when b is negative, we move to the right, and here we are moving to the right by one time instance. As you can see here, we have just moved by one time instant. So this is how you can use the techniques that we have learned so far and then figure out what these values are. Okay, so these are the solutions that we have figured out. Okay. Let's see some more interesting examples. So same thing. Here we have, let's say this is x of t. Now what are our critical points? Let's call these critical points T1, T0 and T2. Okay, these are critical points. Now let's call this signal x1 of t. There is clearly the amplitudes have changed, which means there is a multiplication factor here. Okay. Now what should be the multiplication factor? Just take the point, let's say the 1 here has now become minus 1. So which means minus 1 is c times 1. So c is minus 1. This tells us c is minus 1. Okay, we figured out c. Now let's try to figure out a and b. Has the origin shifted? No, the origin has not shifted because we still have the same points at 1, 2 and 3. So which means b is equal to 0, and there is no stretching or squishing. So just by observation we can just say a is equal to 1. The signal has not stretched or it has not compressed. So this is just x1 of t is just minus x of t. Okay. Now let's see another case. Let's call this as x2 of t. The amplitudes have not changed, so there is no scaling here. So it's just there is no scaling in amplitude here. There is only shifting and scaling in time. So all you have to do is now once again note the critical points V0, V1, V2. Okay. Now let's see what happens to A and B. A is, let's take the points T0 and T1. Okay. So T1 minus T0 is 2 and V1 minus V0 is also 2. It just gives us 1. So which means there is no time scaling, it's just 1. And in order to find B, it is minus A times the shift of origin. Keep that in mind. So which gives us minus 1 times 3, which is minus 3. So in other words, x2 of 2 is x of t minus 3, which also makes sense because this is shifted by 3 time instances to the right. So right means b is negative, and we found out what should be the shift of origin. Now let's see the final signal x3 of t. Now there is a shift of, there is a scale of amplitude. Here you can say it was 1, but you can see that it's 2 here. So which clearly means there is a constant ahead. Okay. What is C? So whatever was 1 before manipulation has become 2, which automatically tells us that C is 2. And once again the critical points remain at the same time instances 0, 2 and 3, which means B is 0, A is 1, which means the solution is just 2 times x50. Simple. Okay, this is the solution we just derived. Okay. Now let's do a little more than just looking at graphs. Let's say somebody just gives you an analytical expression, right? Often we just do analysis. Now from the analysis, let's say it so turns out the signal that we are looking for has this form. Then we want to manipulate this further. What do we do? So given this equation, how do we find out what the signal was? Let's first plot it. Okay. To understand this, the original signal x of t is of this equation that is given here. From this equation, we can clearly say the critical points are -1, 0, and 1. Okay. So mark these points -1, 0, and 1. So the signal is 0 outside -1 and 1. So inside -1 and 1, let's see how it looks. Between 0 and 1, it's just taking a constant value. And within -1 and 0, you have 1 plus t. So the value of t at -1 is -1. So -1 plus 1, so it is 0 here. And the value of this signal at 0 is 1 plus 0, which is 1. So which means you just have to connect these two. So this is our signal x of t. Now, we are asked to find out x of t by 2 minus 1. Okay. So let's do the shift first and then scale second, and let's see what happens. So remember, we had two techniques. First technique is to shift. So if we shift the signal by 1, x of t minus 1. So we have the time intercept be -1, which means you have to move it to the right, and you have to move it by 1 time instant. So which means this is what so 0, 1, 2. Okay. And after this, you can just scale. So it says the value of a here is half. So if the value of a is half, its magnitude is less than 1, which means all you have to do is just stretch it. Okay. And by how much amount you have to stretch? By 2 times. So 1 by 8 times. So you're stretching it by 2 times, which is meaning whatever is at t comes at 2t. Okay. So x of t by 2, that is whatever is at 0 remains the same, the origin does not change, but then whatever is after that, you just stretch it, you just pull it apart, right? You pull it towards the right. So which means this entire signal gets stretched. 0 stays as such. Whatever is 1 gets stretched by 2 times, it means it will appear at 2. Whatever is at 2 once again gets stretched by twice, it appears at 4. Okay. And you can map the critical points and then see what is happening here. So just plug in, let's say, evaluate x of this t by 2 at 2, x of 2 by 2 minus 1, which is equal to x of 0. So as you can see, the critical point here 0 got mapped onto 2 here. Okay. Now let's do the other way around, right? The other step that we saw, that what if you scale first? Let's do that operation. Now if you scale first, you're going to scale by 1 by 2, which means you have to stretch and stretch about the origin. So if you stretch about the origin, whatever is at 0 stays at 0, but whatever is at -1 comes to -2, whatever is at 1 comes to 2. Now after this we are going to shift, but this is where you have to keep in mind that because you scaled first, now you have to shift by b by a. B is -1, a is 1 by 2, which means b by a is -2. So you have to shift by -2. So minus tells us that you have to move to the right, and then 2 says that you have to move to the right by 2 time instances. So moving this to the right by 2 time instances means you end up getting the same that we wanted. So both are the same signals. Okay. Now let's say that y of t is equal to x of, okay. In other words, what we have plotted here is not just x of t, it is also y of t. Now what operation should we do on y of t such that we will get back x of t? Okay. So in other words, you have to reverse this. So as you can see here, what you have to do is now figure out some a t plus b such that this is equal to x of t. This is the reverse operation that we were talking about. So remember, what we can do is the same thing. So you can now scale it by 1 by a and then shift by minus b by a, or just shift by minus 1 and scale by shift by plus 1 and then scale by half. So the other reverse operations we can do. So let's see that. So in this case we know that what the a and b were. So let's see, what if we want to first do this operation, scale by 1 by a and then shift by minus b. So let's say we scale this by, we scale this signal here by 1 by a first, which means you're going to just scale. A here is half, so 1 by a is 2, so y of 2t, you're going to squish it. Okay, so squish it about the origin. So you get 0, 1 and 2. Okay, the other operation is, remember, minus b. B is -1, so minus b is +1, so y of 2t so after this you have to keep in mind y of 2t, scaled version, you are moving it by +1. Okay, so after scaling you're moving it by +1, that is shifting it to the left, then you get the original signal. What if you do the other way around? So what's the other way around? First shift by minus b by a, so and then scale. So shifting is minus b by a, here minus b is +1 and divide by a, you get +2. So you have to now shift by +2. So what if you shift y of t by +2, which is plus means you have to move it to the left. So you get this signal. So this signal is y of t +2. Okay. Now, so this is same as y of t +2. So that makes sense, right? Because this is the reverse operation, and then we are supposed to get, so we did, let me number this so that it's easier to see what's going on. So we did this first and this second, we did this first and did this second, and when we undid the same thing, the first operation, so the first operation that we did here was we started with this y of t, which is essentially this signal here, okay, and then we did the undoing by starting with scaling operation. So when we did the scaling operation, we started with this signal and then we moved here, right? So this is same as this, right? So this is y of t, this is y of 2t, okay? Because here what we did, the scaling was the operation that was done last and that was undone first, and we got this signal. And then here after that you move to, from this signal we move to x of t, which is equal to y of 2t plus 1. The same thing here. So we did the shifting first. So by shifting, we got the first operation to be, the last operation was shifting, that was undone, and we got y of t plus 2. And then you undo this by scaling, and the scaling is going to give you x of t directly, which is y of 2t plus 2. Okay. So in other words, we have here a is equal to 2, b is equal to 2. So we can figure out, or this entire finding out what should be a and b can also be just found out given these two plots directly. How to do that? So that's what we learnt some time back, right? So all you have to do is just find out the corresponding critical points. So here let's say that this is T0, this is T1, and they got mapped onto V0 and V1, and then we know that A is equal to T1 minus T0, which is 1 minus 0, and V1 minus V0, which is 4 minus 2, which is 1 by 2. Okay, so this is giving us the value for x of t. So in other words, this is telling us how to get y of t from x of t. So if you want the other way around, then we'll have to just reverse this, which means we are saying T0, T1 here, and V0, this is the mapped signal, right? So we are saying that whatever was here, that is 4 minus 2, has moved to 1 minus 0, so which makes A to be equal to 2. Okay, if A is 2, then how do you find out B? B is minus A T0. Okay. So the origin was here, okay, the origin is this point and it has moved to minus 1, okay. In other words, this is, the origin's value is at 0 point, has now moved to, this is V0, or this is the origin's location, which is minus 2 times minus 1, which is equal to 2. So that gives us B A equal to 2, B equal to whichever that we were looking for. So this gives a complete picture of how to shift a signal, how to reverse the signal, and how to figure out what are the shift and scale values. Now let's do another example. So you're going to work this example out, okay. So I'll probably just give quick hints of how to do this. What you can do, like we said last time, you can first shift. So by shifting the same signal that we have here, so that's plus 1, so you just shift it to the left, so you get minus 2, minus 1, 0, okay, and then now you have to scale it, okay. So now the scaling is by minus 3, which means the magnitude is greater than 1, so you have to squish it, but then there is a negative, which means you have to flip, so you flip it first, okay. It's always about 0, okay. and whatever was at minus 1 now becomes minus 1 by 3, and whatever is at minus 2, so this is plus, and this becomes 2 by 3. Okay, we can check this and then see what happens. So let's take the point 0, substitute the point 0 here, then you get x of minus 3 times 0 plus 1 should be equal to x of 1, and substitute the point 1 by 3 here, you get minus 3 times 1 by 3 plus 1 should be equal to x of 0, and x of minus 3 times 2 by 3 plus 1 should be equal to x of 1. Sorry, x of minus 1. So which is exactly what we got. So here this point is x of 1, this point corresponds to x of 0, and this point corresponds to x of minus 1. Okay, this is x of 3t plus 1. Okay.